Okay, in this section we will go on with finite state machine. There is typically 3 types of coding style for FSM. The 3 blocks style. Yeah, we have seen it in the 6 detection example. That is, you use 3 always blocks to code the function. One state for the state transmission logic, one state code the state register, and the other always block code the output of the FSM. And also you can choose to use the 2 blocks style. That is, you use one always block to code the state register, and use the other always block to code the state transmission logic and the output. So if you code in 2 blocks style, the output must be combination logic output. Yes. Yeah, that is, you merge the function of the 2 combination logic block in an always block. And also you can choose the 1 block style. Yes, that is coding all the things in only one always block. So this block must be sequential logic. Yes, as your state register must be sequential logic. So the outputs must also be sequential logic. Yeah, and you also use the case statement. But please note that the waveform in this code for the 3 signals, the 3 output signals, is different from the 2 codes we have seen before. Yeah, they are different. The difference is the 3 signal here has 1 more cycle latency. Yes, as it was registered. Okay, it was registered, so it has 1 more cycle latency. That is because the D value here must be 1 cycle before the Q value here. Yes. Okay, this is the commonly used coding style for finite state machine. Okay, let's do a simple compare of them. Actually, there is no big difference for the 3 coding style. Okay, so you can choose as you wish. Which one is simple and which one is easy to implement? Which one is easy to coding? Just choose that one. And 1 blocks and 2 blocks coding style, you need save coding effort. That is, you can write in less lines to coding them. Yeah, this is because you can see in the example. This is because the state transition logic and the output, there may be something similar in the 2 always blocks. Okay, the state transition and the output logic. So if you just choose to write in 2 blocks or 1 blocks, you will save some code here. But this is just the coding effort, okay? The coding effort. You didn't save any area. Okay, and if you want to describe the function of the D pin, that is the D pin of state registers and the D pin of output, you have to use 2 blocks or 3 block style. Yeah, if you define the function of D pin, this may be more flexible compared to the one block style. For example, if you define the value of D pin, yeah, you can use the value here. You can use the value here in other logic blocks. Yes. 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 So, if you describe the signal value here, you can use it in other logics. So you may more flexible to describe this logic. Okay. If you use the 1 block style, you just have the value here, which is 1 cycle later than the D pin. Yeah, if you define the D pin, you can use both the signal here and the signal here to the yes. So use 2 signals, more flexible. Okay. Okay, it seems finite state machine is a efficient architecture to describe some functions. But is there any drawbacks for finite state machine? For example, will it cause less data throughput? Just think about it. I will talk about more hardware architectures in later chapter, such as pipeline and ping pong. So, after the study of pipeline and ping pong, you can compare them with finite state machine and check the difference of data throughput for each architecture. And there is one question for you. If we want to design a more complex sequence, that is a sequence of 7 bits, how will you define your state and state transition conditions? And please note that there is 2 bits overlap, yes, for each group. So the state transition may be more complex than the overlap of 1 bit. And for some other functions, there may be 3 bits or 4 bits overlap between each group. Then it will be much complex. So how to deal with these situations? Yeah, how to define the finite state machine? Please think, is there another way to handle the sequence detector except the finite state machine architecture? Is there any better architecture for this problem? That's all for this section. Thanks.